Hello, today we are recording on the editor I use because I don't really like some wording I used. These past 10 days I've been thinking of what to do. Since believe it or not, I, I don't know how to teach percentages properly because I don't know if it's just me or because I think percentage people sometimes don't get. That's the personal thing I have seen with my own friends. So hopefully this works out. Before we start, like, subscribe, and share. And okay, percentages. So we'll be covering two topics in this video: percentages and money. Yeah, I have hiccups today. So if I am starting to get them, so don't mind that. Percentages. What's a percentage? A percentage is represented by the percent symbol. X percent is read as X percent. As mentioned in fractions, decimals, and percentages in the second video. Percentages are a way to tell a part or a portion of some quantity. Like how a fraction is, a percent is somewhat like a fraction because the percent literally means 1 out of 100. Percent, per out of, cent 1 over 100. You know how the dollar is cent. That X percent means X parts out of or per 100. Percentage can also be above 100 as well. Example: 140% is I got 140% back of the original price, meaning he got the original price and 40% extra. We will talk about these greater percentages later. This of the original price in a second. Expressing quantities as percentage. We can use percentages to quantify one quantity size in relation to another quantity. Example: if you want to know what percent is 20 boxes out of the total 150 boxes, what do? We get the fraction 20 over 150, and we multiply it by 100%. I want you to note down this thingy. 100% means 1. Why? Because 100% is what? 1 over 100. 100 times 1 over 100 is 1. So this, it means like we are multiplying with a 1 here, but actually but because how percentages work, we multiply the 100 and we keep the percent. It's like a way to like show that, hey, this is how we can get the original value. It's by dividing by 100 to get the original fraction, which is this. In general, if you want to express quantity A as a percentage of another quantity B, we write A as a fraction of B before converting A over B into a percentage. I hope you guys understand this. You might be doing this for your scores, marks, for the other exam papers also, and have been doing this since 8th grade. Finding the percentage of a quantity. We can now this is the part where I lost hope. But yeah, basically we can see 12 is it's not that rocket science, just me, sorry. Basically when we have like expressions like find X percent of Y, it means just multiply X percent by Y. That's it. I don't know why I'm making it complicated for myself or for you guys. This is meaning equals this, the of meaning multiply, and then the 12 meaning the original thingy. That's how it is. X percent of y meaning x percent times y is equal to z. X percent of y is z. That's how in English we say. So this is how the thing works. We can see that to find x percent of a quantity A is multiply x percent with A and done. Now x percent can and is treated as a fraction, meaning you can say example 3 is 1/4 of 12, 3 is 24% of 12, or 3 is 0.25 of 12. Okay, this is a bit weird to say. But generally you might see these two terms in the examination. Find a 3/5 of a quantity, find 11/12 of a quantity, find this percent of a quantity, blah blah blah. Percentage change. A change in the value of an item can be expressed as a percentage increase or decrease in its original value. Now, this breaks down into two parts, increasing and decreasing. Okay, these are similar. Just the thing is that the context of the change value. Okay, now this thingy here, new value minus original value, this increase and this decrease. Okay, you can think of it as the change. Okay, the change value. How much is are the two values, original and the new value, like different by. Okay, you know how in physics you have change in temperature. Okay, you find by how much the temperature changes. It's the same thing here, but it's with either it's increasing, it's new value minus original value, or decreasing, where it's old value minus new value. Next is the formula to find the new value. Original value, you add the increase percent. Okay, you add the increase percentage. Okay, increase percent you will be given or have to find it. In the origin and in decrease you have to subtract the decrease percentage, which you will be given or have to find it. And that's how the new value is. So let's look at the English that I've written, so you guys can get a better understanding. An increase in percentage means to add increased percent of the original value to the original value. The increased amount is difference of new value and original value. Here you can see here. This bracket here, I've just grouped it. Okay, grouping. Else it literally means what I said. Add increased percentage of the original value. If you increase, if you like expand this bracket, you get original value plus original value times increased percent. And this new value is the value we get. Okay, this will be greater than this value. Okay, remember, original value will be smaller than the new value. Hence, this is why we do this. Okay, because this is bigger, this is smaller, we get a positive number. Okay, you guys know addition, right? Subtraction. If a man, okay, here's an example. If a man earns $240 per year and gets a salary increase of 8%, what is the salary increase? We know the percentage, but it increases by, and we know the original salary he was earning. We want to know how much additional money he is now getting. Okay, the increase amount. I call this the increase amount. Okay, so we do this to 40. This we increase the value by 8%. 8% is what? 0.08. 1.08 times 240, we get to this value. Next, you find the difference between the new value, a new salary, and the old salary, and we get that he's now getting an additional $19.2. Okay, this with this new salary he's getting. Okay, so he had a $19.2 increase. Okay, the value might increase by, this percent is the percent by it increased by. Get it? You can work backwards to see the increased percentage. Example, in 2014 Ali's factory made 25 units, but in 2015 it now makes 20 units. Oh, 20 units more. Oh, sorry, 20 units more. What does it mean? It now is making 45 units. Find the increase percentage in production. Now we can use this thingy to find that the new value is 45 and the change is what? Change is 20 units. Okay, the new value minus the old value is 20, so new value is what? 45. You can just find this any other method that seems fit. Next, we know that when 25 is increased by some percentage x to find 45. This is some basic algebra setting up. Okay, this is a different kind of worms. Okay, but since we are going by the syllabus order and not in terms of how a textbook would go, we just have to use this thingy, setting up algebra equations even before studying algebra. Yeah, that's the thing. I think, then this makes me agree with how textbooks go, where they first they skip over a few chapters, they quickly jump to a few chapters, building base, and they go back, which uses that earlier base of the multiple chapters to complete the earlier chapters again, some parts of it. Anyways, let's get back to this. Okay, we can see this. We divide both sides by 25. We get 1.8. We have this thingy. Okay, this 1 plus x percent. X percent is what? 1 over 100. We subtract 1 on both sides, so we get this value. Okay. Next, we multiply 100 on both sides to get x is equal to 80. What does this mean? It means that the factory now makes 80% more units than last year. Okay, this is how you can think of it. Decrease. A decrease in percentage means to subtract decrease percent of the original value from the original value. The decrease amount is difference of original value and the new value. So you guys can see this. Decrease percentage is subtracted. If you expand the bracket, we get original value minus original value times decrease percentage. Okay, is equal to the new value. Example: the death rate in a city is 1,000 per year. But the next year it decreased by 30%. Calculate the death rate of the next year. Okay, I think we can word it a bit better. Nah, English works fine. Okay, so we can see that we find the new value, which is 7,000, which is like how we expected, is less than the original value. Hence, this is why the original value is first in this equation now. Okay, it's not that we changed it because of fun. It's because to not have a negative number. Okay, this is why I say the difference. Okay, instead of increase decrease. Okay, because the difference can be negative or can only be a positive because of how we describe difference. Okay, it cannot be a negative value. A negative difference is this addition. So this is why we have the original value in front in decrease and the new value in front in increase. Okay, to have the value be positive. So you find the difference. Old original value was this, new value is this. So we see that the death rate of the next oh no, we have to do this. Bruh. You guys saw nothing. We can work backwards and see the decrease percentage. Okay. Example: the price of the car was for 40,000. After a accident, the price decreased by 400. Calculate the decrease percentage of the price of the car. Now you know how this works. 4000 minus new value is equals to this. New value is what? Now this number. We find the decrease percentage and see that it decreased by 1%. That's pretty good. I hope the car crash didn't do that much. Comment down below which was the, if you ever had an accident. I hope not. But if you had, unfortunately, how much did it cost, and how much did your car loses its price by? Anyways, back to here. Reverse percentages. Okay, you think that we are doing this step is reverse percentages? But yeah, it's okay, right? This is where we are giving the percentage and the final value, and we need to find the original value. Okay, we can count this as a reverse percentage technically, but this is a bit different, where you find the original value, then the percentage change. Okay, because this is asking us what x percent of what gives us the answer. Okay, instead of what percent of x gives us the answer. Okay, this was what percent do we multiply the first quantity by to get the second quantity. This is here. Now here is what quantity do you multiply this percentage by to find this answer. Okay, it's like this value is the unknown. Okay, so it's like a progression, right? And normal percentages, you find the answer, and in percentage change, you find the percent or the answer again. Okay, the percent, and in reverse percentages, you find the original value. See how it goes? Okay, example, a discount of 50% brought the price of an item down to 200%. Find the original price. So how do you know this? How do you see this? A item has the original value something. We are on a sale and it went down by 50%, and now you have to pay 200. Now you're wondering, what quantity that I pay half 50% of is 200. Okay, so you find the original price that the item was on sale for, which is 400. What do? We divide this, we literally divide this bracket by divide it over here, and we find the original value. Another example, after a tax of 5%, the price of the food rose up by $1.9. Find the original price of the food. Now this uses percentage change also. Okay, it's like these are the most annoying questions, where it uses two ideas at once. Okay, and this is why people call them difficult questions, because I don't know what's with people using two ideas at once for the question, or for a part of a question. Let's see. So how do we do this? Let's take it step by step. We know the difference is what? 1.9. Okay, and we aren't given the new value and the original value. This is what people might cry about, that hey, we aren't given sufficient data. We do not need sufficient data. Why is the question even made if it, right? Why is the question even verified to come in your paper or in the exam if it cannot be even solved? Okay, here we know the new value is what? 1.9 plus the original value. We plug it into the formula, dilly dally. What is it? This similar formula. No, what is it? Yeah, this one. We plug it into this formula. Okay, we rearrange this to get the new value. What is new value? Increase plus the original value, and we equate it. Okay, I hope you guys can see this. Okay, original value plus 1.1 plus the increase amount, increase percent is equals to increase amount plus the original value. What are we asking ourselves? Original value. Okay, what is 5? What 5% of a value will give us 1.9? Yeah, that's what you are asking. Okay, so what do? We take this, we bring it over here, expand this bracket while you do so. So we expand this bracket over here like you see, and we have this original value which we borrowed to here. Next we have this going on, original value times 0.05 is equals to $1.9. We divide 0.05 on both sides and you get this value over here. Ta-da! We found the difference in the price. I hope you guys can understand. If you guys want, I can give you guys a different example to visualize, to better concrete this example. Okay, I think we will be doing questions anyways, so who cares? Okay. I hope you guys, understood all that. Get like a little break. Nah, this is a video. I have to complete the syllabus. Yeah. Exponential growth and decay. When we measure the population of some bacteria, decay of unstable atoms, or the population of people in a place, or the compound value of a car, or heavy machinery and finance, we use exponential growth or exponential decay to express this gradual growth or decay of them or of the price in the financial part, whatever. The general formula that fits the trend is ax to the b, a exponential formula. Okay, now this you might want to remember this. Okay, this little quote. This will be used in graphs of functions later. Here we are expected to use the formula this, where A is the final population, P is the initial population, R is the rate at which it is growing at, and T is the time period. It may be in hours or days, years, blah blah blah, whatever. Okay. So this is the formula that we use. Okay, A is equal to P, this to the T. What is this? Is the P, and this is the this value, this big bracket over here, and this B is the time period that we have. Let's look at the uses. Okay, what are we given and how do we do stuff with it? When the exponential growth, when the question says the population increases exponentially, the population growth increases by R% every year, this stuff, okay, it should remind you to use this formula where the R is positive. If we see increase and R% growth and R%, this means the value of R will be positive. Okay, this plus will be a plus with given conditions in the exam. The population, okay, here's an example I made up myself. Okay, there's like barely any questions for this. I looked at like multiple papers while finding questions for you guys to do. Okay, there's like barely any. So this might be the only video with questions for this very topic. Hopefully, we have this honor. Okay, the population growth, the population of a country increases exponentially at a rate of 3.6% per year. See, increases exponentially, exponential growth. Okay, increase, growth, yes, at a rate of 3.6% per year. See, per year. Okay, on the 1st January 2024, the population of the country is 5.4 million. Calculate the number of complete years it will take for the population to reach 8 million. Okay, now this is some complex thingy, let me break it down for you bit by bit. One is setting up our equation. You guys know how to do this. Okay, what is our final value? 8 million. Okay, how much it should reach? 8 million. 5.4 is the initial population. 3.6 is our percent by it is the rate by it increases by, plus because of exponential growth, and t. We have to find the time. Okay, the time period. So what we do, we solve for this. Now what we cannot solve this, okay, because this is not a thing in our syllabus. Those who LARP the syllabus will be like, oh no, we have to use logs, we have to use this. No, sorry, but you do not have to go out of the syllabus to solve a question. There's a different method we do this. We use trial and error method to solve for this. We plug in the values of t until we get the value. Okay, this might, okay, I hope you guys understand what I'm doing here. Okay, so we plug in like 1 2 3 4 blah 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 till this value is greater than this. Okay, till calculate the number of complete years it will take for the population to reach 8 million. Now it does not mean exactly 8 million, else that would be using logarithms and stuff. We want complete years. Okay, we do not work with a fraction of a year. No, we work with complete years. So we will find that after 12 years the population has reached or is a little over 8 million, but approximately 8 million. Okay, this is what we have, inequality. This inequality that we show. Now when you get this 12, okay, when you're satisfied with this is our final statement. Okay, here you find that t is equals 12, the population reaches about 8 million. I'm not saying exactly 8 million, about 8 million. It takes, so what do you say, it takes 12 complete years for your population to reach 8 million. If you were to use a calculator and calculate this value, okay, you would see it's like a bit less than 1.48. Wait, sorry. Yeah, this value should be greater than. Okay, I was like, I was confused also. Why is this a mistake? No, 1.48 should be less than. Okay, this will be greater because we are like overestimating, because we are taking full years into account, not like a part of a year. So this value will be a bit bigger. Okay, this is a tiny bit bigger. Okay, but it will be somewhat close to this value. Okay, about 8 million. If we do 11, okay, 1.036 to the 8. Yeah, you guys can see this value is like a bit less than this value, 1.48. So that's why we choose the next number, 12, which is bigger. Okay, this is the first time it is bigger than this value. This is how we know that we need to use the value of 12. This comes with practice. Okay, I'll do some questions you guys answer. Example, the number of bottles of fruit drink sold has grown exponentially at a constant rate of 2.5% per year. 5 years ago, the shop sold this many bottles. Calculate the number of bottles sold this year. Okay, now we look at this carefully. What is this? The 5 years ago, the shop sold this much. This is the initial value. Okay, and this year, 5 years ago and this year, it means after a period of 5 years. Okay, so that means surely when the sales increase, this final value should be greater, right? Bigger than our original value. So what do you do? Original value, this 2.5, this is a plus because it's exponential. Oh my god. And a period of 5 years as stated, and this is the thing. So what's our final statement? The bottle sold this year is what? 18,804. Nice. Very simple. Lastly, a lake now contains 9,700 fish after 5 years of 14% annual growth. Okay, how many fish were there initially? Okay, you guys can see how this works. Fish after 5 years. Okay, so in a period of 5 years, the fish grew by 14% annually, and we reached a good population amount of this much. We solve the equation and we get p is equal to 5039. Okay, now I remember, wait, yeah, the value is not exactly this number, but you cannot have like a pot of a fish, what do you call it, like a baby like a fish which is not yet a quote adult. No, just round it up, it's okay. Round it up. Now on to exponential decay. Exponential decay has the r value be negative. Okay, here we had it positive, here it's just negative. Why? Because this value decreases as as this exponential rate value increases, so that's why it's like exponential decay. The value decreases because you're multiplying a smaller value each time. And exponential decay has the r value be negative with given conditions in the exam. It's the same equation, but with r being a negative value. Okay, as in this will be a minus. Okay. Example: the population of a town decreases exponentially at a rate of x% per year. In 2020 it was this much, and in 2023 it's this much. Down. Decreases exponential decay. Same, r value will be negative because it goes down. Find the value of r. So you set up our equation. Since January 1, it will be 3 years for January. Since 2020 to 2023, the time period is what? 3 years, right? So it will be final value. Okay. Yeah, this is the final value. Oh, what the? Wait. So the equation you just saw was wrong, the working. But yeah, I fixed the working. So what do we do? Time period is 3. Our original value was 120,000, and our new value is 102,885. Damn, it's so hard to read numbers. So what do? We divide this by this. Okay, divide this by this. Next, what do? We take cube root on both sides. This gives us a very amazing value. Okay, I'm not doing any approximations. Okay, then I put the 1 over here. 0.95 minus 1 is what? Negative this value, and I multiply negative 100 on both sides to get what? X is equal to 5 as our answer. So we know the population of the town decreases exponentially at a rate of 5% per year. Good to know. Next example: the mass of a radioactive substance decays exponentially at a rate of 10% per day. Okay, here is it per day. I wanted to change it up a little bit. The initial mass of the substance is 20 grams. And the final number of whole days it takes for the mass of the substance to first be less than 1 gram. What do we want? Its mass to be less than this value. Okay, so here is the correct value, less than. So you set up our equation. What is our initial? 20. What we want, and the final 1. What we have? This the time period and this exponential decreasing. What do? We forget to put a new line in here. in the code. Yeah, next we divide 20 on both sides to get this value. Now we will use trial and error to solve for this and plug 40 until we get a value to be first less than 1 gram. Now this is by over 20. If you guys want, you can still keep the 20 over here, and this will give the value a similar value. If you guys see that at 28 days it's still above, but after 29 day it's this is the first time it goes below. And obviously if we divide both sides by 20, what do we get? This value 0.047, which is less than 0.05. Hey, fine. So the statement is, after 29 days the mass of the substance becomes less than 1 gram. Okay, less than 1 gram. Population of the town is 54,000. The population is decreasing exponentially at a rate of 2% per year. Calculate the decrease in the population at the end of the 4 years. Okay, so 54,000 minus, because it's decay, and 2% per year, time period is 4, and we get this value. Very easy. What do we have next? So that was exponential growth and the percentages chapter. Before we do questions of percentages, let's quickly cover money first. Okay, let's start. Money. Everyone loves money, like Mr. Krabs, no? And this is part of the percentages and also money. Okay, by percentages I mean this profit and loss thingy and discount. The remaining is then part of money. You know, this is going to be an expensive conversation. So what do we have here? Same as percentages, but with extra terminology. Now we just have profit and loss, which is same as increase or decrease, but with money in context. Profit is when you get more than you spend. Example, if a manufacturer produces goods at a certain cost and the goods are sold at a higher price, it is the selling price and the cost price, the manufacturer makes a profit or a gain. The amount profited is new value minus old value, or in here the selling price minus the cost price. Yes, I have not looked at this document before recording, as it is evident in the previous cases. So you know, profit amount is this selling price minus cost price, and the profit percent is what? Profit over cost price times 100%. I literally don't know what happened to me when I was doing this. Okay, let's see. And now, as I told you before, 100% means 1 and blah blah blah. Rewind the video if you do not know what this means. Example, a bag costs $28. If the bag is sold for $40, express the profit as a percentage of the cost price. So this is what does this mean? Basically, we want to find what percentage profit. Okay, we just want to find the profit percent. So this change, okay, this $12, meaning he got 42.86% more and then what he spent. Basically, that's what this is. Example, another one. If a bicycle is sold for, just read it in the editor. If a bicycle is sold at $2,000 and has a profit of 8%, find the cost price. So remember, he has a profit of 18%. What is the profit? It is selling price minus cost price. Okay, he sold it at 2000, that's his selling price, and the cost price is X. We do not know how much he spent on it, so let's that. Original price is this, cost price. So we do this is equals to 18%, and we do algebra, divide everyone by multiply. Yeah, this becomes 1, this becomes 0.18. Okay, just simplify this. Next we do x on both sides. Okay, we get this, we shift the x over here. Okay, we add x on both sides, so you get 1.18 and 2000. Divide 1.18 on both sides, you get this value. Now this value has no number to it, has no unit to it, but in the answer space it will be like this much dollars. Okay, this much dollars he got. Okay, so this is the value he got, and this is in 2 decimal places because the least count of money, which is $0.01 or a cent. So that's why we have money in up to 2 decimal places always. During working, yes, you can use 3 decimal places, but when you are giving your answer in terms of money, you will give it in 2 decimal places always. Keep this in mind. Okay. Loss is when you get less than when you spend. Okay, very simple. If you guys experience it, then you know properly what this is. Why didn't my connection go? Wait. So, example, if a manufacturer produces goods at a certain cost and the goods are sold at a lower price, it is the selling price, and then the cost price, the manufacturer makes a loss. And here I also have not changed the values. Let me do that. Exactly 1-to-1 copy mistake that I made previously. It's almost as if I copied the entire segment again and just changed some bits around. That's true, but moving on. Let's look at the examples I have here. Example: a bag costs 28. See? Now this is, okay, you guys can read this. You guys understand this. Okay, so what happened? He lost 50% of what he paid. He lost $14. That's such a big amount to lose in today's world. You really got to choose who is at the front and who is selling your thingy. Example: if a MacBook is sold at $800 and had a loss of 33.3%, find the cost price. So we do the same algebra shenanigans over here. Now the value over here is like repeating 4. If we had a bit more digits to work with, it's like proper 12,000. Okay, so round this to like 12,000. I just had a rounding error and stuff. It's because of the question itself, so you can't blame that. If I said like 100/3%, then it will work. Screw it. The reason profit and loss formulas have the term swapped is to have a positive value. I don't know why it have this paragraph over here but not in the above. If we didn't, we would find quote negative profit, which is loss, and vice versa. In profit, the old value was the cost price, and the price you bought in the past, the old value was the cost price, the price you bought in the past, and the new value is the price you sold it at in the future or in the present, which is higher than the cost price, and the difference is profit. Same applies for loss. In loss, the old value was the cost price, the price you bought it in the past, and the new value is the price you sold it at in the future or in the present, which is lower than the cost price, and the difference is the loss. Yeah, I think this is self-explanatory. I like this paragraph. Let's keep going. A discount is applied to a product if it's not selling. A discount is applied to a product if it's not selling good or need to clear shelves. I mean, it is true. Okay, don't look. Maths is all about the truth. Okay, so there's clearly some relevance you have to give to the viewer before doing the math and getting them twisted around your stuff. That is why the price you sell it at during a discount is the sale price and the original selling price before the discount is marketed price. So you can see marketed price minus sale price is what? Discount. Marketed price is what? The price it is shown, which is bigger, which is like originally without the sale the discount. And sale price is when the sale is open, like 50% off. So obviously the amount you have to pay will be less. So that's why it's in the second place. And the marketed price is the bigger, higher price. Okay, that's right. Nowadays nobody pays the marketed price unless they are desperate to buy that clothes, or that the company does not usually do sales and blah blah about that. Okay, next we have discount over marketed price times 100%, which gives us discount percent. Okay, and remember the 100 stays. The 100 goes here and the percentage is kept. Example: a piece of clothing is sold at 200. After the discount is now sold at 154. Find the discount percentage. So what do? We find the discount amount. Then we do this discount amount as the percent of the marketed price, which is 200, and hence you get the discount percentage. I hope you guys understood that all. Just final two topics left before getting on to questions. Simple interest and compound interest. Interest is the cost of borrowing money or the reward of saving money. Okay, the cost of borrowing money or the reward of saving money. I've done good research on this topic. You can never go wrong with money. There are two types of interest: simple interest and compound interest. Okay, now before I start, I want to have you guys keep this in mind. Some questions will be such that they ask you that, hey, there's like these two banks. This bank is doing this, this bank is doing this. Which bank is more profitable, makes more, saves more, gives you more, blah 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 blah. I think it comes with practice. I've seen these types of questions with 4024, and I forgot which questions I put in my own question list for today. Simple interest. Interest is calculated only on the original amount. P, principal amount, is starting money, at some rate for a certain amount of time in years. Okay, time will always be in years. If it's in months, then you got to convert it in years. Okay, what is interest? Principal times 8% times time, or PRT over 100. Okay, I just have it in separate terms. Over 100 is the percent, and P is the principal, R is the rate like I have here, and time is the T. To calculate the total amount we paid, okay, the amount we paid or the amount that we get, what is it? Amount is equal to interest plus the principal amount. Very simple. Okay, if it asks you find the total amount of interest, it means to only calculate this value I. But if it asks you to calculate the total amount, then it means to calculate the amount you got, the total amount paid. Okay, because I did this mistake in my own paper I do not know what happened to me, literally. I just made this very simple mistake. I've done this question, this topic a billion times, but I guess confidence takes over, I guess. Compound interest. Compound interest is calculated on the original money plus the previous interest. The total amount is calculated by increasing the principal amount by the rate for the given time in years. Here we directly have the total amount calculating for us, and this equation is wrong. Yeah, there we go. Equals. Amount is equal to principal plus over 1 plus rate percent to the time. Okay. Here we have this, and here we have this. Now some people might say this is exponential growth with money. Yes, sure. But for myself, I keep these two formulas different. Okay. I keep these two formulas a bit different. But because of context, they might be the same thing. Okay. Sometimes yeah, it's hard. Okay, sometimes finding exponential growth and decay questions. And because of this similar thingy. Moving on, to calculate just the compound interest and the extra money, okay, the money that we got, like we build up over the years, we just subtract the P from the A. Recall how this amount is equal to interest plus principal. Here the interest variable is C. Okay, we just move P on that side, so that's why the equation is like this. Okay, if the time is in months, divided by 12 to get it into years. Very simple. Exchange rates. Only like very teeny tiny bit I've written. People around the world uses different currency units. To unite the world, we set conversion rates between different country standards of different countries. Example, US dollars is different than Japanese yen and different than Pakistani rupees or Indian rupees. I don't know what that unit is. USD to Japanese is 156, to PR is 280. Now, this value obviously is like very outdated as hell. Okay, because it changes like every hour or so. And so do not question the accuracy of these questions. It's just that to make the calculations easier for you guys. In paper 1, if you get it in paper 1, it's easy to simplify. In paper 2, then you would have to use the calculator to do your shenanigans. Questions will supply the conversion rates as ratios or in terms of equivalence. Example, $1 is 162 yen. Okay, either they will use the currency symbol or that they will use the like this 3-letter thingy like we have here. I hope you guys understand that all. So check the next video for the questions. Okay, since the video is like already an hour long, okay, after like looking at the edit I made, and since the next questions video is also approximately an hour long, so you guys should check the questions video. And then like, subscribe and share, and bye.